Welcome back. We are going to continue the concept of sets. I have a few definitions I want to go through with you. The first definition we have is a finite set. A finite set is a set that either contains no elements or the number of elements in the set is a natural number. For example, if we have the set C, and C is equal to 1, 2, 3, 4, and 5. This set is a finite set. The reason this is a finite set is because we have 1, 2, 3, 4, 5 elements. And 5 is a natural number. Now, the opposite of a finite set is an infinite set. An infinite set is a set that is not finite. For example, the counting numbers are an infinite set. So if you remember, the counting numbers is a set that starts with 1 and then goes 2, 3, 4, and so forth. It doesn't end. If you try to count all the members or elements in this set, you couldn't do it. It keeps going forever and ever. So the number of elements in this set is not a natural number. That's why it's an infinite set. Okay, a few more definitions. This is where it might get a little confusing, so I highly recommend that you write these definitions down. We say set A is equal to set B if and only if set A and set B contains exactly the same elements. And the symbol for that would be, we could write it like this: A is equal to B. Another definition that we have is this thing called the cardinal number. The cardinal number of a set A, the symbol for this looks like this: a little n parentheses A, whatever the name of the set. Whenever you see this, you read this as the cardinal number of set A. Or the cardinal number of a set is how many elements is in that set. So for example, let's say we have set A, and it's equal to 1, 5, and 7. The cardinal number of set A would equal, it would equal how many elements are in set A? Well, there's 1, 2, 3 elements in set A. So the cardinal number of set A would be 3. All right. Another definition we have is called equivalent. Set A is equivalent to set B if and only if the cardinal number of set A is equal to the cardinal number of set B. And the symbol for equivalent is an equal sign with the tilde sign above it. So if you know two sets are equivalent, we could write it like this: set A is equivalent to set B. And then the last definition we have here is called the empty set, or the null set. The empty set is a set that contains no elements. Okay? There's two symbols you can use. You can just put the two set symbols with nothing inside them. Or you could put a circle with a slash through it. Both of these mean the empty set, which is also called the null set. All right, so I want to do some examples here. So we're given 3 sets up here. Set A is equal to the set that contains cat, dog, and fish. Set B is equal to the set that contains apple, orange, and grape. Set C is equal to dog, cat, and fish. All right, I got these statements. I want to decide, are these statements true or false? Well, let's look at A. It says set A is equal to set B. Or two sets are equal if and only if they have the same elements. Well, what are the elements in set A? Cat, dog, and fish. What's the elements in set B? Apple, orange, grape. Are these the same elements? No, they're not. So, this is a false statement. Set A is not equal to set B. So we could write it like this. A is not equal to set B. This is a false statement. Set A is equal to set B? No, that's false. All right, let's look at B. B says the cardinal number of set C is 4. Well, if you remember, the cardinal number is how many elements are in set C. So all you gotta do is count the elements in set C. Well, we got dog, cat, and fish. So we have 3 elements. So B is also false. To make this true, we could write it like this. The cardinal number of set C is equal to 3. All right, let's move on to C. C says set A is equivalent to set B. The only way two sets are equivalent is if they have the same cardinal number. Well, the cardinal number of set A is 3. So there's 3 elements. The cardinal number of set B is also 3. So what that means, this is a true statement. This is true. Set A is equivalent to set B. And then the last example we have is D. D says set A is both equal and equivalent to set C. Well, to be equivalent, they have to have the same number of elements. Well, both set A and both set C have 3 elements. So they are equivalent. Now, are they equal? Well, to be equal, remember, they have to have the same elements. Well, in A, we got cat. Do we have cat in C? Yep. In A, we got dog. We got dog in C? Yes. And then in A, we got fish. And in C, we also got fish. Are there any elements that's contained in A or C that's not in one or the other? No. So these are equal. So this is a true statement.